Hey everyone, welcome to Algebra 1 Equations, and this is going to cover difficult practice problems. We're going to start by solving equations with the variable on one side. So here I have 3 1/5 plus c is equal to 4/5. I don't like having a mixed fraction with a proper fraction, so I'm going to change this mixed fraction to an improper fraction to make the math easier. So that will be 16/5 plus c is equal to 4/5. I'm going to subtract 16/5 to isolate the variable of c. And now my answer is negative 12/5. Problem number 2. I have f plus 7/4 equals 2/3. I'm going to isolate the variable. So I'm going to subtract 7/4 minus 7/4 on the other side to get f is equal to 2/3 minus 7/4. These fractions do not have the same denominator, and that's what you want to make the math easier. So I'm going to do some side work over here. 2/3. I want it to get to a common denominator. When you're looking for common denominators, you want to see what is a multiple, the smallest multiple that you can find to convert them to. And in this case, it's 12. In order to get this 3 to 12, I had to multiply it by 4. So I'm going to multiply the numerator by 4 as well. And that's going to give me 2 times 4 is 8. And then for this one, 7/4, I want to get the denominator to 12. In order to do that, I had to multiply it by 3. I'm going to multiply the numerator by 3. And so the new fraction is going to be 21/12. So we'll come here and we will do 8/12 minus 21/12. And that is going to be negative 13/12. For number 3, we have mixed fractions and some mixed fractions. I'm going to change them to improper fractions because that makes the math easier. So 3 times 1 is 3 plus 1 is 4. It's really 4. Another way to write that is 4/3 times s is equal to 3 times 2, which is 6, plus 2 is 8, 8/3. Now, to isolate the variable, I'm going to multiply by the inverse. So I'll make this red for this occasion of this fraction. So I'm going to multiply this as well by 4/3. Oops, sorry. 3/4. 3/4. These are going to cancel out. And then I have s by itself. This is going to cancel out. I can reduce this because they both have a factor of 4. 4 into 4 is 1. 4 into 8 is 2. So then I have 2/1, which is also the same thing as saying s is equal to 2. In this one, we are going to get rid of these mixed equations. Mixed fractions. So 2 times 4 is 8, 9/4 is equal to 8, 9/2. I'm going to multiply this fraction next to the variable by the inverse, which is 4/9. So then I have to do that on this side. That cancels out. My variable is isolated. I can reduce that. I can reduce that because 2 goes into 2 one time and 2 goes into 4 twice. And then I have 2/1, which is also equal to e/2. All right. For this one, I have 15 over 4b minus 15 equals 33 minus 4. The first thing I know that I can do is isolate my variable more, try to isolate it. So I'm going to add 15. So I'm going to add 15 over here, and then I have 15 over 4b is equal to 33 over 4 plus 15. Now, this is over a fraction over 4. This is a fraction over 4. This is not. I want to make it into that so the math will be easier. So let's do some side work of fraction work. 15 over 1 is a different way of saying 15. And I want to get it to 4. So I had to multiply this times 1 times 4. So I got to multiply the top by 4 as well. And that's going to get me 60. So I can rewrite this as 15 over 4b equal to 33 over 4 plus 60 over 4. Simplifying some more, that's 93 over 4. Now, to isolate the variable, I'm going to multiply this side by the inverse of 15 over 4, which is 4 over 15. So I'm going to do that here on the right side as well, 4 over 15. That cancels out. B is isolated. Now, I'm going to do the math here. Simplifying the math, I'm going to break it down as far as I can. That can be canceled out. These two, 15 and 93, have a factor of 3. So 3 into 15 is 5. 3 into 93 is 31. So it's 31 over 5. Six has a few terms and has parentheses involved. This is going to require some simplification. So on the left side, we'll start with 4a plus 2. Now, I'm going to distribute this negative 1 to the inside of this parentheses. So it's going to be negative 12a minus 8. Same thing here, distribution plus 10a plus 6 is equal to 6 plus 12, which is 18. Now I want to combine like terms. So I have a positive 4a, a negative 12a, and a positive 10a. So 4 minus 12 is negative 8, plus 10 is 2a. And then I have 2 minus 8 is negative 6. But then a plus 6 is 0. So those cancel out. And then I have 18 on the right side. I'm going to divide by 2 to isolate my variable. And then I have a, which is equal to 9. Solving equations, but these equations have variables on 2 sides. Okay, so looking on the left side of this equation, I have 2 terms where there is a b, negative 8b and positive 8b. So I'm going to simplify that. That is going to be b plus 6 is equal to negative 17 plus b. Okay, I'm going to get the variables on the same side. So I'm going to subtract b. That makes it equal to 6 is equal to negative 17. 6 is never going to be equal to 17. So the answer to this is no solutions. Sometimes your answer is not going to have a solution. As long as you show your work, you'll be fine. Let's do the second one. There's going to be a lot of simplification involved. I'm going to distribute the 3 into the inside of this parentheses, the terms on the inside of this parentheses. So I have 6f minus 3 plus 5, and distribute this 6 into the terms on the inside of this parentheses, 6f plus 6. 6f I have to leave alone, but negative 3 and 5 I can combine. So it's 6f plus 2 is equal to f plus 6 I'm going to try to get the like terms on the same one. So 6f canceled out, and then that leaves me with 2 is equal to 6. Again, that can never happen because 2 is 2 and 6 is 6. So we have no solution. Specifically put this in the problem set because I wanted you to see that it is possible that sometimes you're going to have no solutions. You'll see in later lessons in Algebra 1, you'll have multiple solutions or just one solution, like most of these questions are. For number 9, at least in this problem set. For number 9, we have equation involving fractions. So we are going to try to simplify as much as we can. So on the left side, simplified, but on the right it is not. So let's just drop down everything on the left side. 2 over 3x minus 1 over 4 is equal to 2 over 3x. I'm distributing what's on the outside to the terms that are inside of the parentheses, and that is 2 over 12. Going to try to get the like terms. Let me put 2, and this is a negative, I believe. Hold on. Negative 2 over 12. Okay, let's try to get this on that side to get the variables on one side. That cancels out, and you get negative 1 over 4 equals to negative 2 over 12. That is never going to be true. This is also a scenario where it's no solutions. And some side notes. In this problem, we multiplied fractions. In this situation, it was 2 over 3 times negative 1 over 4. It's negative 2. Just multiply the top to get the top answer and multiply the bottom to get the bottom's answer. And then you can break that down even more so to negative 1 over 6. So no solution sometimes is your answer. Whoops, excuse me. Okay, I believe this is the last problem. Number 10 involves fractions on both sides. And let's get started. So I notice that each fraction has a different denominator. And when you can, it's advantageous for you to simplify your fractions. And a way of them being simplified is that the denominators are the same. So over here, we're going to do some side fraction work. And with each fraction, we're going to find the common denominator. So I think of multiples, but the smallest multiple. If you compare with 3 and 2, you could do 6, but 6 is not a multiple of 5. So let's do 10. 10 is not a multiple of 3. And I'm just arbitrarily guessing till we get high enough. So we realize 6 is not. Let's go a little bit higher to 10. It is for 2, but not for 3. Okay, if it doesn't work for 1, it doesn't work for all. So if we're at 10, can we do 12? We can do 12 for 3. We can do 12 for 2, but we can't do 12 for 5. So let's do a multiple of 5. That's close to 12. Let's do 15. We can do it for 3, but not 2. Okay, so let's do some more multiples of 5. We're at 15, 20. 20 doesn't work for 6. Or those. 25 doesn't work for 3. 30 works for 3, works for 2, works for 5, works for 6. So it's 30. All right. To get to 30, I had to multiply that by 10. So I'm going to do that here. To get to 30, I had to multiply that by 15. 30, I had to multiply that by 6. To multiply that by 5. So now the answer is 20 over 30, 15 over 30, 18 over 30, 25 over 30. Now we're going to rewrite everything we did here to this side. So 2 over 3c is now 20 over 30c plus 1/2 is now 15 over 30 equals 3/5 c, which is now 18 over 30 c minus 5 over 6, which is minus 25 over 30. Now I want my variables on one side, so I'm going to do, I have a positive 18, I'm going to do a negative 18, 30c, negative 18c is equal to 2c plus 15 over 30 equal to negative 25 over 30. Now I'm going to subtract 15 over 30. I'm going to subtract 15 over 30 on the right. That's canceled. I have 2c is equal to negative 40 over 30. Now this 2 I'm going to divide by 2. So I'm going to divide by 2 on this side as well. Let's back up, guys. Whoops. I missed something. Okay, so now 20 over 30c minus 18 over 30c is 2 over 30c plus 15 over 30 is equal to negative 25 over 30 minus 15 over 30 minus 15 over 30. Now you have 2 over 30c is equal to negative 40 over 30. I'm going to multiply by the inverse, which is 30 over 2. So I'm going to multiply over this side, 30 over 2. Now I get c, and this is going to be canceled, the 30 and the 30. 1, 2 goes into 1, 2 goes into negative 40, negative 20 times. So the answer is negative 20. Thank you guys for tuning in. I hope this was helpful, and I will see y'all in the next video.